next topic is the conformation analysis of the ethane. The molecular formula of the ethane is CH3. The carbon in the ethane exists in the tetrahedral geometry and the valency of the carbon is 4. So in the ethane, the 3 valency of the carbon is satisfied by the 3 hydrogen atom and the other valency of the carbon atom is satisfied by the carbon. So the tetrahedral geometry of the carbon is represented by the number of representation method are available for drawing the three-dimensional or tetrahedral geometry of the carbon. So we have to study the two representation. First one is the Sohor's projection and second one is Newman projection formula. So these two projection you are already studied in your plus 2 classes. So first is the Sohor's representation. In the Sohor's representation, the Cc carbon atom is viewed in the above, in the top. So the top representation is the Sohor's projection representation of the ethane. The second one is the Newman projection of the ethane, in which the front carbon atom is represented by a dot and the back carbon atom is represented by a circle and the hydrogen is attached to it. Okay, so consider again we are moving back to the ethane. In the ethane, consider the Cc sigma bond as a spring. So if you are fixing the one end of the spring and we are rotating the other end, we will get the infinite number of the three-dimensional arrangement. So these are represented by the bottom of the slide. So first of all, the ethane is represented in the Newman projection formula. So in which we are I mark the two hydrogen atom in the red color. So these hydrogen are just behind the other. So this conformation of the ethane is known as eclipsed conformation. So if you are rotating the 60 degree, you will get the staggered conformation. In the staggered conformation, both the hydrogen are 60 degree apart. So if you are again rotating, we will get the next. That means the rotation is 120. The total rotation is 120. We will get the representation like this. So similarly, we can rotate the molecule up to 360 degree. 360 means 0 degree itself. So these are the conformation possible for the ethane, in which we can see that the most stable conformation of the ethane is eclipsed and staggered, in which least energy conformation of the ethane is the staggered. And so we have to study only the two major conformation of the ethane, that is the eclipsed and staggered conformation, in which staggered conformation is more stable than eclipsed conformation. This is because in the staggered conformation, both the hydrogen are maximum distance apart. So it is the staggered conformation having the least repulsive energy. That's why the staggered conformation is more stable. Whereas in the case of eclipsed conformation, the hydrogen is just behind the other. So that's why they attain the maximum repulsion. That's why the eclipse conformation is least stable, having higher energy. Next we are going to the potential energy level diagram or changes during the rotation about the Cc single bond of the ethane, in which we are starting from eclipsed conformation, that is least stable, having higher energy. So while we are drawing the graph, at 0 degree rotation, the molecule exists in the eclipsed conformation. Eclipsed conformation are having the higher energy. So we have to draw in maximum height in the y-axis. And then if you are rotating the 60 degree, we will get a staggered conformation. Staggered conformation having least energy. So we are drawing in the downward and touch the x-axis. Again, if you are rotating the 60 degree, we will get the eclipsed conformation. So we are drawing the energy level into upward. Okay, so likewise